Earlier this trimester, we learned about how to use stoichiometry, and we learned that you can take the grams of a substance and you can convert that to moles, and then you can use the balanced equation to convert from the moles of one thing to the moles of something else. Okay, and so typically when you do stoichiometry, you start with the grams of the substance. Okay, we've also learned using gases that you can use N equals PV over RT also to find the moles. And then once you have those moles, you can use the balanced equation to convert from moles of one thing to moles of something else. So you can start with grams, you can start with pressure, volume, and temperature, and you can find moles either way. Okay, we've also learned with solutions, though, that when you take the concentration, the molarity, and you multiply by the volume in liters, you also get moles. Okay, and it's the moles of the solute, the stuff you're dissolving in the water. And what can you do with those moles of solute? The same thing we do with grams, the same thing we do with pressure and temperature and volume, is you can use stoichiometry to convert from the moles of one thing to the moles of something else, just like what we've already learned. Okay, let me show you an example of this. Example number 1 says 250 milliliters of a 0.5 molar solution of sodium sulfate is added to excess ammonium chloride, producing blah, blah, blah. Write a balanced equation for this reaction. So first of all, we've got Na2SO4 reacting with NH4Cl. It's going to produce NaCl and NH42SO4. So I've got 2 sodiums, so I'm going to put a 2 there. That makes 2 chlorines, and we have 2 ammonium, so we need a 2 there. Okay, so our equation is balanced. Now remember, just like before, if let's say we had, forget this part, let's say we had 25.2 grams of sodium sulfate in excess ammonium chloride. Remember that is telling you, oh, if the ammonium chloride is excess, then that is our excess reactant, which means the other one is the limiting reactant. So that means that our 250 milliliters of a 0.5 molar solution is the limiting reactant. Okay, and so since they give us the volume and the concentration of that solution, we can convert that to moles, just like what we've already done in our previous videos. Take the concentration in molarity, take the volume in liters, multiply them together, and you get moles of Na2SO4. Now, pretend we converted grams of Na2SO4 to moles. So again, 25.0 grams of Na2SO4. We use the molar mass, and we get moles of Na2SO4. Okay, same thing. Either way, you're getting moles of Na2SO4. Now that we have moles of Na2SO4, what would we do in the past? Well, we'd use the balanced equation and go from moles of Na2SO4 to moles of something else. Guess what? You do the same thing. We take the moles of Na2SO4, we put them on the bottom, and then we use that balanced equation. 1 mole of Na2SO4, and again, in this problem, they're asking us about salt, about NaCl. So we go to 2 moles of NaCl. So 1 mole of Na2SO4 makes 2 moles of NaCl. And then our final step is we convert the moles of NaCl to grams using the molar mass of NaCl. And then we just go to our calculator and we get our final answer there of 14.6 grams of NaCl. Okay, so there's our stoichiometry step. The only thing that's changed is at the beginning. How do you get to moles? You convert grams to moles. You can use PV equals nRT to get moles. And now we know we can use solution. We can use the volume and the concentration also to get moles. So example 2, let's do this one together. An excess of potassium phosphate, so again, excess, which means it's going to be extra, is added to 15 liters of 0.050 molar silver nitrate, forming blah, blah, blah. What mass in grams of KNO3 is produced in this reaction? So first of all, like always, we have to have a balanced equation. Okay, so we've got K3PO4 reacting with AgNO3, forming KNO3, and silver phosphate, Ag3PO4. So 3 potassiums, 1 silver, 3 silvers on the right-hand side, so I need a 3 there, and that is now balanced. Okay, so our first step is, again, they give us the concentration, they give us the volume, so what am I going to do? I'm going to take 0.050, and I'm going to multiply by 15 liters. Okay, so 0.050 times 15 equals 0.75 moles. 0.75 moles of what? Well, it's 15 liters of 0.05 molar silver nitrate, so AgNO3. So that means we have 0.75 moles of AgNO3. Okay, and again, they're asking us about the mass of KNO3. So we're going to go 0.75 moles of AgNO3. And then from the balanced equation, 3 moles of AgNO3 are going to make, remember they're asking us about KNO3, is going to make 3 moles of KNO3. And then we can say that 1 mole of KNO3 has a mass of 39.1 plus 14 plus 48 equals 101.1 grams. Okay, and now I go to my calculator and I get a final answer of 75.8 grams of KNO3. Okay, and again, this is really just a stoichiometry problem where, again, at the beginning, we're simply taking the concentration times the volume to get moles rather than taking the grams and converting to moles. Okay, example number 3. This one's a little bit trickier, but again, nothing more than what we've already learned. Notice right away we've got the volume and we've got the concentration of H2SO4. So what am I always going to do? Anytime they give me the volume and the concentration, I'm going to get moles. Okay, so 0.500 times 0.0457 liters. So 0.5 times 0.0457 equals 0.0229 moles of what? Of H2SO4. Okay, and oops, I forgot to do the balance equation here. Let's do that real quickly. So we've got H2SO4 is required to completely react with NaOH. So we've got H2SO4 plus NaOH produces, and it tells us, water, H2O, and Na2SO4. Okay, so to balance this, it looks like we need a 2 right here and a 2 right here, and now it is balanced. Sorry, that end's driving me nuts here. There we go. Okay, so that equation is now balanced. So we've got moles of H2SO4, and they want to know the concentration. And remember, concentration is just another word for molarity. What's the molarity of this NaOH solution? We have the volume of the NaOH solution. We're just missing what's concentration? It's molarity, which is what? Moles over liters. So if we already have the liter part, what are we missing? We're just missing the mole part. So I can take 0.0229 moles of H2SO4, and now I'm going to use the balanced equation. Okay, 1 mole of H2SO4 is going to react with 2 moles of NaOH. Okay, and that's going to equal 0.0457 moles of NaOH. Now they want to know the concentration. So again, concentration is molarity, so that's moles on top. 0.0457 moles of NaOH. The volume is 0.0200 liters given to us there in the problem. So 0.0457 divided by 0.0200 equals 2.29 molar would be the concentration of that sodium hydroxide solution. So again, with concentrations, with molarities, the only thing that's different is rather than converting grams to moles, you're using concentration and volume to convert to moles. And then you just do the rest of the stoichiometry problem like every other stoichiometry problem you've done this year.